Today we'll cover absolute value equations and multi-step inequalities. Just as a brief reminder, absolute value always represents a distance. Okay, so if you're looking at 0, distance goes in two directions. You have distance goes in the negative direction and the positive. But we know that absolute value is always positive because it represents a distance. So we're always positive with absolute value. So when you're solving absolute value equations, step number 1 is always to isolate the absolute value bars if you can. So I'm going to say absolute value bars if possible. So looking at this first example, the absolute value bars are isolated on each side or on either side of them, so we're good there. So once they're isolated, what you do is you drop the bars and then you set up a second equation that's identical with what was in the bars and then to the negative of the answer. And now we're solving both of these. So if you subtract 8 from both sides, you get 4. If you subtract 8 from both sides, you get negative 20. So both of these are part of our answer. And you always want to check for what we call extraneous solutions. So to check for extraneous solutions, an extraneous solution is an answer that you get that when you plug it back in, it doesn't make sense. So if we're checking here, we'll put 4 back in for x, and you need it to read true. So 8 plus 4 is 12. The absolute value of 12 is 12. So that makes sense. And then if you put negative 20 back in, the absolute value of negative 20 plus 8, negative 20 plus 8 is negative 12. The absolute value of negative 12 is 12. So both of these solutions work out and are answers to our equation. So go ahead and try this next one. So the absolute value bars are isolated. So we drop the bars and set up a second equation. Add 4 to both sides. What's that? Negative 7. Okay, check for extraneous solutions. So the absolute value of 15 minus 4 needs to equal 11. It does. The absolute value of negative 7 minus 4 needs to equal 11, and it does. So both of these are answers. All right, so we have two more problems here. So what you want to do is you want to isolate the bars. So we're going to add 5 to both sides. So we have 3 times the absolute value of 2x minus 3 equals 9. Never, ever distribute this number in. Absolute value bars are different than parentheses. So we're actually going to divide both sides by 3 to get rid of it. So now I have the absolute value of 2x minus 3 equals 3. Never distribute. If you need to write that down, do it. Never distribute. So we're isolated. So we set up our equation. And I need to make another note that I think I forgot to say. If once your absolute value bars are isolated, it must be set equal to a positive number. If it is set equal to a negative, it's no solution. So what I mean by that is, let's say I had x plus 1 equals, so there's nothing on the outsides of the absolute value, negative 1. This situation would be no solution. Because remember, absolute value is a distance, so it has to be positive. Okay, so sorry, I just spoke in the middle of this problem, but that needed to be said. Okay, so now I'm going to go back and solve these two. So 2x equals 6, x is 3. Here 2x equals 0, x equals 0. So I'm going to plug these both back in to make sure that they make sense. So 3 times the absolute value of 2 times 3 minus 5. That whole thing needs to equal 4. So this in the absolute value, that's 6 minus 3 is 3. So 3 times the absolute value of 3 is 9. 9 minus 5 is 4. So then go ahead and check for 0. It works. So both of these are solutions. All right, so here's another one. If you notice on the left-hand side, the absolute value is isolated. So this is where it gets a little tricky when you have a binomial over on the other side of the equation. You have b plus 5 equals 2b plus 3. But then you also have to set up the negative equation. So you're gonna have b plus 5, but you have to make everything on the other side negative. So essentially you're distributing a negative through. So negative 2b minus 3. You can't just change the sign of the first term. So when we solve the left side, I'm going to subtract b. So I get this. I'll subtract 3. So I get 2 equals b. And then over here, I'm going to add 2b to both sides. And then subtract 5. And we get negative 8/3. And when you check those, they both work out. All right, so we're gonna look at a word problem here. A standard adult tennis racket has a 100 square inch head plus or minus 20 square inches. Write and solve an absolute value equation to determine the least and greatest possible sizes for the head of an adult tennis racket. Plus or minus are your key words here. When you set up an absolute value problem, the plus or minus number is gonna be what you set it equal to. Okay, so 20 square inches is after the plus or minus, so that goes on the other side of the equal sign. So here this is saying the central value is this C value here. So this is kind of like a formula that you're gonna use to set up an absolute value equation. So plus or minus is the set equal to. And then the central value is the other number that's included in the word problem. So you have a 100 square inch. So in our formula here, it says x minus, and then I'm just gonna fill it in with this 100. So I have x minus 100 equals, or the absolute value of x minus 100 equals 20. Drop the bars. Make a second equation. Add 100. So the greatest is 100 square feet. Was it feet? LOL, no, it was inch. My bad. So this is that. And then the least is 80 square inches. All right, finally, we are going to solve some multi-step inequalities. You solve them just like equations. When you multiply or divide by a negative number, you flip the inequality sign. So if it's less than, it becomes greater than, and vice versa. You have to use a number line to graph one variable inequalities. Open circle for less than or greater than. Less than or equal to or greater than or equal to gets a closed circle. I'm also going to give you a little guide on interval notation. Interval notation is another way to represent a solution set. So if you have less than or greater than or an open circle, you use parentheses to represent your interval notation. If you have or equal to signs and a closed circle, you use brackets. If you have a left arrow, that represents negative infinity, and infinities always get parentheses by them. If you have a right arrow, that's a positive infinity, and again, infinities always get parentheses. So you might be like, what is she talking about? We're gonna see some examples of multi-step inequalities, and then we're gonna provide interval notation for the solution set. So you'll see examples. Okay, so let's see this one. So we have 12 minus d is greater than negative 8. So the whole goal is to isolate the d. So minus 12. So now I have negative d is greater than negative 20. And d is not isolated yet. I have to divide both sides or multiply by negative 1. We know that when you multiply or divide by a negative number with inequalities, you flip the sign. So d is greater than 20. Okay, so that's my answer. I'm gonna put it on my number line. I don't need anything fancy. I'm gonna put a 0 and a 20. That's enough for me. The sign is less than. Less than gets open circle. And the solutions, D is smaller than 20, so the solutions go in the left direction. Okay, so that's how you graph it. And then for interval notation, you read your graph left to right. So if you go back to that guide on the last slide, you'll see that a left arrow represents negative infinity. So this graph starts with the left arrow. So if we're reading it left to right, we're starting with this left arrow. So we start with a negative infinity. And we know that negative infinity gets a parentheses because all infinities do, comma. And then you find where you stop on the graph. So we're stopping at 20. So 20 comes next. And 20 is an open circle. And from our last slide, we know that open circles also get parentheses. So your interval notation is negative infinity to 20. With interval notation, you can have a parenthesis paired with a bracket or vice versa. It almost looks like an ordered pair. So you only have 2 values per parentheses. And also with interval notation, you'll never see a negative infinity come after a positive infinity. Okay, negative infinities should always be on the left side of a set, and positive infinities should always be on the right side of a set. So you never want to see this, 20 to negative infinity, because that doesn't make sense. 20 doesn't come before a negative infinity. Nothing comes before a negative infinity, so that's wrong. All right, let's look at this next example. Here we want to multiply both sides by 4 to get rid of that denominator. So that'll cancel here. So I have 2x minus 9, is less than or equal to 4x plus 8. I'm going to get everything on one side. So I'm going to subtract 2x. So that'll leave me with 2x over here. And then I'm going to subtract 8. So that's negative 17. So divide both sides by 2. So x is greater than or equal to negative 17 over 2. I'm a creature of habit. I like to have my variable on the left side. So see how the open side is with the x over here? Keep the open side with the x. Okay, there's my answer. Let's graph it. So 0, negative 17 halves is somewhere over here. It's like negative 8.5. Closed circle, because it's or equal to, and x is bigger, so it goes that way. Interval notation, we're starting at negative 17 over 2. It's a closed circle, so it gets a bracket. And then we're going forever in the right direction. A right arrow means positive infinity. Close the parentheses. Okay, a few more examples here. See if you can figure them out. I'm going to go ahead, I'm going to multiply this whole thing by 4. That's going to get rid of my fractions. So I end up having 1n plus 48 is greater than or equal to 3n minus 16. A lot nicer to work with. Subtract n from both sides. Add 16 to both sides. Divide everything by 2. So n is on the right. 64 divided by 2 is what, 32? And I told you I like to just have my variable on the left side. Graph it. Doesn't have to be perfect. Closed circle, left. Okay? Interval notation, we start with a negative infinity because it's a left arrow. We stop at 32. Bracket because it's a closed circle. So this whole thing is part of my answer. Okay. Looking at this other example, I'm going to multiply this whole problem by 20 because if you look at the 5 and the 4, that's the common denominator or at least common multiple. So when you're distributing it here, 20 divided by 5 is 4. So really what you're doing is you're multiplying this whole thing by 4. So 9 times 4 is 36z minus 16. Then we have a less than or equal to. And then over here, 20 divided by 4 is 5. So you're multiplying this whole thing by 5. So it's 35z plus 10. Subtract 35z from both sides to get z. Add 16 to both sides to get 26. So z is less than or equal to 26. 0, 26, close circle, left. Interval notation starts with a left arrow. We stop at 26, bracket, done. All right, one last word problem. We're talking about a gymnastics competition. An athlete's final score is calculated by taking 75% of the average tech score and adding 25% of the artistic score. All scores are out of 10. One gymnast has a 7.6 average technical score. What artistic score does the gymnast need to have a final score of at least 8? Geez. Okay, we're talking about two types of scores. I'm going to let T equal my technical score, and I'm going to let A equal my artistic score. Okay, so if the gymnast can earn 75%, you want to express that as a decimal. This is one of the situations where decimals are okay. 75% of the average technical score. So of means multiply, T represents technical. And adding, okay, so that's plus 25% of the artistic score, so that's 0.25 A. Okay, and then let's see, what artistic score does the gymnast need to have a final score of at least? So at least means greater than or equal to, because it can be 8 or bigger than 8. Okay, we have one other number that's thrown in there for us, and it's that 7.6. They're telling us that that is the technical score, so we're going to plug that 0.76 in for T, or I'm sorry, 7.6. I'm losing it over here. Ignore what I just did. Okay, 0.75 times 7.6. This is why I hate decimals. 0.25A greater than or equal to 8. Okay, so now we're just solving this problem for A. So when you multiply these together, you get 5.7 plus 0.25. This is the point. A greater than or equal to 8. Subtract 5.7 from both sides. So I have 0.25A is greater than or equal to 2.3. Divide by 0.25. So A is greater than or equal to 9.2. So they need to get an artistic score of at least 9.2. That's your final answer. All right, that's a wrap on this review section. Let me know if you have questions.